Hello students, let us learn about autoencoders in this session. So as you can observe, autoencoders is one of the main dimensionality reduction deep learning methods which can be used for all applications. So first let us go into the theory part and then let us come back to the diagrammatic representation which can give you a better understanding. So it is a generalized form of PCA. As we have already known, principal component analysis takes only the most important features of any input data. So slight variation with more layers give results to the type of auto encoders. And it is mainly used to generate codes in the sense your original data will be available in the compressed form when you look at the output. This is the place where we say that my compressed output is equivalent to a dimensionality reduced output. And the training methodology which we adapt in autoencoders is unsupervised methodology. So when I say unsupervised methodology, you must automatically bring in all the characteristic features of the unsupervised methodology techniques such as non-availability of targets and lack of error and other techniques. And now when you say we are going to generate codes which is equivalent to a encoding process, we also have a decoding part. However, the decoding part is used only to check the correctness of codes, but our output is not exactly obtained from the output layer. Now with this information, let me go and show you the diagrams. So you will have different number of layers and your condition is the input layer neurons should be always equal to the output layer neurons. So as we saw in the first diagram, the main reason for that is your output is going to be checked against the input in the output layer. So only when you have equal number of neurons in both the layers, we can have a check. The number of hidden layer neurons are always lesser than the other layers. This is another special condition in autoencoders. As we know that we are going to reduce the dimension of the data, so whatever you are going to get as output should have a lesser size than the original layer. So what we are going to do is you have a original layer neurons and you also have a hidden layer neurons, but the number of hidden layer neurons are going to be very less. And this layer corresponds to the code in the compressed form. So this is where we are going to say that my output is going to be available in the reduced or the dimension compressed data. The training algorithm is same as that of PPN. So this is the architecture scenario. Now, when you come to the training part of the algorithm, we have already learned about backpropagation neural network. If you are new to this video, you can refer the literature. So the same stochastic gradient descent algorithm is used here too. But there is a small change between the conventional BPN and the autoencoders. Here in autoencoders, we are trying to reach the target in the sense that your output and input are trying to be matched together so that we are going to get an equal output. If your output is exactly same as that of your input, so we can say that your error is equal to 0. Now people may ask some questions that because we already said that BPN falls under the category of your unsupervised methodology, how can we have this target? We don't have a physical target, but we are considering it as a virtual target where we try to match the difference between the output and the input. So these are some of the properties of autoencoders. They are data specific. That means if you train a specific data, then only that data can be compressed or reduced using autoencoders. Again, it is going to be mostly lossy because there may be some loss of information. So if you feel that your application demands a lossless dimensionality reduction, then it is advisable you do not go for autoencoders. There are some other methods which you can prefer. And also we have an unsupervised learning technology because we do not have an explicit target to run on, even though we assume the comparison between output and input as a supervised mode. Four hyperparameters which you need to set right when you are training an autoencoder. One is the code size, which is the number of nodes in the middle layer, the number of layers. You can have as many layers as you like. It doesn't matter. If you want the data to be reduced to a highest possible extent, then you need to have a small number of neurons or less number of neurons in your internal deep layer. Number of nodes per layer, as you have seen that it's a stacked encoder where you find that it's like a sandwich. All the layers are sandwiched between another two layers. So make sure that the number of nodes per layer is not very complex so that you will get the best possible output for your application. And the last function is either a mean squared error or binary cross entropy. As we have already learned, your regression makes use of mean square error and your classification makes use of binary cross entropy. Depending upon your need, you can choose any one of the loss function. So this is how your original image and the reconstructed image will look like. You can see the original input, some digits are given here. At the end of the output layer, we try to have this output. So even though there is not an exact match, still you can find that the data remains the same in the sense that your codes which are obtained in the internal part of your architecture is the correct. Thank you for watching. We will look at the different types of autoencoders in the next session.